On to the next one. Alp, James Kong, are you here?
Yes, I am.
Perfect. Please, the floor is yours.
Okay, I'm going to try to share the documents. Let me know if this comes up.
Yep.
Okay. Okay, should I start?
Please.
Okay. Hi, everyone. My name is James Kong from Alp Technology. Actually, it's really exciting to be here today. That's because we're a company that mainly been in stealth for the last almost 7 years. And this is actually one of the first time in a larger forum that we are talking about what we do and showing in public. So the system in front of you is kind of our version of what the future of batteries look like, battery systems look like. So this is probably reminiscent of what a Tesla power pack or power wall people would think about. And we've been spending the last 6 years to make that battery storage more affordable, and using data, AI, and really clever mechanical and electrical engineering. And this battery is actually one of the most affordable in the world. I know it's kind of a bit shocking to say. It's at a cost about 30. This one is about 30% less cost than the equivalent battery system, which I think in this case is a Tesla Powerwall. And we've been also, in addition to system, there's a system in our office that's been running our manufacturing sites in London, UK, for over 2 years now. And this is the bigger version of the system that's out in the field. Let me go to the next slide. So apology for the slide. I think one of the biggest questions that we always get is like, how do you end up making a battery that's significantly low cost? So I think there are multiple factors, and please don't read through all that. Listen to me, and I'll try to explain it as simple as is possible. But again, I only are capturing one portion of it. I guess if you think about a typical battery module, they are often 50 kilograms or like over 100 pounds. Our battery module, is about 3 pounds. And so it's similar to a brick, and that's where the name gets from. So instead of using large electronic device, instead of like kind of engineering something that weighs a person, the electronics, the hardware we use is something that comes from smartphones. So now smartphones and telecommunication has about 40 years of miniaturization of electronic devices. So often our component cost, our kind of electronic cost, is less cost than the cabling and the connectors from a larger systems. So that's one main factor we'll be able to do. And then another thing that I probably mentioned in the previous slide, and I'll move on actually from this slide because this is way too complicated. And I will address this. And one of the main reasons we can get this system is actually able to get to 60 to 70% less cost. Because what I haven't talked about is that the way we build the system, when you build it in such a different module and use smartphone electronics, as opposed to large scale industrial electrical equipments for battery building, you use a completely different architecture. And the architecture changes that instead of Tesla using one brand, have to build a gigafactory to spend $2 billion and a 10-year partnership with Panasonic. And you have a battery from the ground up, from software, hardware, to electronics, to use one type of cells. Our architecture allows us to use multiple types. And effectively what we're able to do, the differences between manufacturer on the same battery type is also a difference between a used battery and the new batteries. So that means that right now, for the last 2 years, we've actually been running batteries from one of our suppliers of used cells, which you don't pay anything for. And this is, we're able to handle heterogeneous cells, battery from different manufacturer to use cells. So there, we're actually achieving something that is 50% less cost than a Tesla Tesla Powerwall. And it has potential in mass manufacturing to reduce the cost by 70%, which is something that I can talk about that we're doing in Asia right now. So obviously, when we use on the topics of not just using our system for new cells, when you end up using repurposed cells, a little known fact that a lot of used battery at the end of the EV life cycle still has about 70, 80, and sometimes 90, in real world, 95% of capacity left in them. They're currently just thrown away. Meanwhile, we have to mine the same minerals in developing countries often to get the same chemical. So the idea of reusing battery is not new. But here we have real case study that we can extend this battery, right, 2, 3, 4, over 10 years of life. So I don't know about you. I think in terms of a kind of resource scarce, energy scarce world, I think one of the first things that we use actually should be reused, and it comes with economics of less than 50%. That's always, I mean, nothing more can be more circular economical. So this, again, I will, kind of touch this slide because this is on a new cells to new cell comparison. Again, we compare ourselves here to Tesla. They're one of the lowest cost grid scale, larger scale battery system, and we're about half this price. And as basically from that reason, the payback period, the project payback for our projects over the world, the last 3 projects over the world is about close to half of similar systems. So I'm just going to go through quite quickly. I mentioned about earlier on the case study in London. Instead of, we discovered that we can do this, well, we've been researching for the last 7 years. We did the first prototype, the big prototype 2 years ago. So we actually built, this is our kind of mini manufacturing site in London, and the entire site is run by the 2 battery systems right there. There's solar panels up in front. So at that point, we're about 290 kilowatt hours compared to 600, which is the current price per kilowatt hour. And what we've done since after we ran it for over a year and had really good data, we expanded to the sites. And you can see that already the cost had jumped down another 30%. That's because at that time, our supplier, which is one of the largest e-mobility, micro-mobility company in the world, they provide us with their end-of-life cells, and we ended up not paying for those cells. So that site right now we're probably one of the only systems in the world that can run heterogeneous, mixed use, new and different chemistry. So primarily the chemistry here is lithium ion, which is what we've been working on. I think I will stop here because hopefully I have questions, but other than that, yeah, thank you.
Thank you very much, James. Any questions for Alp Technologies? Ryan.
I have so many questions. It looks like great technology and some real innovation going on there. But a couple of concerns that that immediately came to mind when I was listening to you was compact storage of batteries always creates somewhat of a hazard. Let's say you're putting a lot of cells together in a small location. The safety features was one issue that I was concerned about. The second one was maintenance. If you're putting together both hybrid cells, technology, chemistries, as well as new and used, when one of those cells goes bad, how do you pull that out of the entire array, and then how do you service that to keep it back online? Is it modular enough to be able to do that? Is that simple? How costly is that? Those are the 2 questions that came to my mind.
Oh, Brian, excellent questions, and thank you for that. So we have 120 fundings from in US and Europe on different innovation funding, and the majority of those was on safety. It was on AI and safety. So on the thermal management side, I mean, that's a very important part. So we actually have one of the most advanced, because we use heterogeneous cells and end-of-life cells, we already have one of the most advanced thermal management and safety management. So this goes back to the module when a battery weighs a human or weighs a brick, a 3-pound unit. It means that individual unit, you can now track these cells very closely. If something happens in that unit, which is 3 pounds, that unit gets shut down. It doesn't kind of propagate to the next one. So that's an entire architectural framework that allowed its kind of safety not to propagate. I can go over some of the phase change, some of the chemistry that we did. I mean, chemistry not in batteries, but different chemistry, kind of thermal management system we put on top of it, and also every single cell is fused. But I think we have a good 6 years of research, and probably this is not the forum. The other factor about maintenance, perfect. I mean, like we see this addressing not Tesla, it doesn't belong EV, it doesn't belong rich person's home. I think there's about 2 to 3 billion people in the world that currently still use diesel generators for electric generation at least part of the day. I mean, think the entire continent of Africa, think India, think Indonesia, think a large part of Asia. So we actually really feel that to truly turn the world renewable, you need energy solutions, because the sun does set, the wind is quite intermittent, and with our cut for energy, it's very tough to transition to fossil fuel. So anyway, I'll stop here. But anybody feel free on those two questions to contact me.
We unfortunately have to move on. We're actually already late. Thanks a lot, James. Super exciting. That sounds like a next big unicorn. Good luck with everything.